One of the uses of IV fluids is for the physiologic maintenance of life, or else the basic hemodynamics of life gets misbalanced. There are 4 primary ingredients in IV fluids that are essential to maintain our daily life: water, sodium, potassium, and dextrose. These are the 4 primary essential substances used in maintenance IV fluid therapy. We need 30 ml per kg of water per day. For example, a man of 70 kilograms will require 2100 ml of water per day. Sodium is an element that has an atomic number of 11 and atomic mass of around 23. We need 1 milliequivalent per kg of sodium per day, which means 4 grams of table salt only. Potassium is an element that has an atomic number of 19 and atomic mass of around 39. We need potassium around 1 milliequivalent per kg per day. The last one being dextrose, and we need around 100 grams of it per day. This is the final list of the primary ingredients of maintenance IV fluids. Water is mentioned as ml, dextrose is mentioned as grams, sodium and potassium ions are mentioned in milliequivalent. We understand milliliter, grams, liter, kilograms, etc. But many of us fail to know exactly what an milliequivalent means. Is it a unit of weight? Or is it a unit of size? Or is it a unit of volume? What is it? To understand this, we need to learn few very essential basic concepts. The concept of mole. We know that a set of 12 eggs together makes a dozen of egg. Suppose we decide to name a bunch of 100 eggs together and we call it a century of eggs. So, a bunch of 200 eggs will be 2 centuries of eggs. A bunch of 500 eggs will be 5 centuries of eggs. Let us do one thing. We decide to call a bunch of 6022 followed by 20 zeros number of eggs together as a holy cow of eggs. Now, if we have 2 sets of 6022 followed by 20 zeros number of eggs, then we will have 2 holy cow of eggs, right? This number, when it is simplified, looks like this. In the world of chemistry, this number is called a mole of a substance. Therefore, 1 mole of egg means there are 6.022 into 10 to the power 23 number of eggs. Obviously, we do not use mole when we express a set of eggs. Rather, we use dozens. In the world of chemistry, mole is an unit used to mention a set of molecules or ions or atoms of an element. 1 mole is a set of 6.022 into 10 to the power 23 number of particles. This is a unique number and is called Avogadro's number. So when we say a mole of a substance It means that there are 6.022 into 10 to the power 23 number of particles. It means a bunch of Avogadro number of molecules, ions, or atoms in a sac. We will call this sac as a molar sac in this presentation for our convenience. In this molar bag, there can be 1 mole of carbon atoms, or it can be 1 mole of calcium atoms, or it can be 1 mole of calcium chloride molecules. Why molecules here? Because calcium chloride is a molecule, not an atom. Here we can see that there are 5 sacs containing 6.022 into 10 to the power 23 number of atoms in each bag. So we have 5 moles of atoms in total, right? Here we have a container containing some substance. Try to think how many molecules are there in it. Here is a tablespoon of table salt. Think how many molecules of sodium chloride is there? Or how many sets of moles you can make with these molecules? Here is a glass filled with some solutes in it. Think how many moles of solutes can there be in it? We usually say a dozen of banana or a dozen of eggs. We can also say a mole of banana or a mole of egg. But we use moles to denote molecules, ions, or atoms for practical purposes. Here we have a dozen of eggs, which weighs 50 grams. Now we see a bunch of these eggs in a basket. The total weight of these eggs in the basket was found to be 500 grams. We know that the weight of 1 dozen of eggs is 50 grams. So we can very well find out how many dozens of eggs are there in the basket. Don't you think so? It's simple mathematics. We take the weight of all eggs and then divide it with the weight of 1 dozen of eggs. Total weight of the eggs is 500 grams, which is divided by the weight of 1 dozen of eggs, which is 50 grams. That equals to 10 dozens. So 500 grams of these eggs will make 10 dozens of eggs, right? Now, if you are given 10 grams of salt and you are told that the weight of 1 mole of the salt is 2 grams, can you find the number of moles present in this 10 grams of salt? Pause this video for a moment and think. Excellent! You have guessed the answer correctly. Let's have a coffee together as I speak further. Periodic table is a great tool that gives a clue about some of the important properties of elements like atomic number, atomic weight, and so many others. Here I have selected 3 elements from the periodic table: sodium, chlorine, calcium. This number reflects the atomic mass of the element. The element is sodium and the atomic mass is around 22.99. This means that 1 mole of elemental sodium will have a weight of 23 grams. This is chlorine, and 1 mole of chlorine weighs 35.45 grams. This is calcium. I hope you can guess by now 1 mole weight of calcium. Haha, you guessed it right. Great. So just keep this in mind that the weight of 1 mole of a substance is equal to its atomic weight. So, how do we know how much moles are there in a given amount of a substance? The very first thing we need to know is the total weight of the given substance, and then we must know the weight of 1 mole of the substance. We already know now that the weight of 1 mole of the substance will be the atomic weight of the substance. This gives us an idea about how many moles are present in a given amount of a substance. For that, we need to know the total weight of the substance that has been given to us. Then we need to know the weight of 1 mole of the substance. And we know that 1 mole of the substance is equal to the molecular weight or the atomic weight, which can be found from the periodic table. Thus, the formula of mole will be total weight of the substance in grams divided by the molecular weight or the atomic weight in grams. That means it will denote how many molar bags will fit in a given weight of the substance. In this example, we have 6.022 into 10 to the power 23 number of molecules, which is 1 mole. Let's say that the weight of 1 mole of these molecules is 14 grams. Now we have a basket containing these molecules, which has a total weight of 280 grams. We have already been told that 1 mole of these molecules weighs 14 grams. Now we need to find out how many moles are present in this basket. We use the formula to find number of moles that are there, which is total weight divided by the weight of 1 mole. The total weight is 280 grams. The weight of 1 mole, which is 14 grams. Hence, we get the answer 20 moles. That means this basket will have 20 moles of these molecules. In other words, it means that it can accommodate 20 such molar bags, right? In this example, we have some amount of sodium in a container. In order to find the number of moles of sodium that the container has, we have to use the mole formula. The first thing that we should do is to find out the total weight of sodium that is present in the container, and we find it to be 23 grams. Now we need to know the weight of 1 mole of sodium, which means its atomic weight. To know the atomic weight of the substance, we refer to the periodic table. You can see now that the atomic weight of sodium is approximately 23. So 23 is placed in the denominator. Therefore, the answer is 1 mole. That means 23 grams of sodium is equal to 1 mole. In this next example, we have a container that contains some amount of sodium chloride. Now, let us use the formula of mole. The first thing that we need to know is the total weight of sodium chloride that is available in this container. As you can see now that the total weight of the available sodium chloride is 9 grams. Let us put 9 grams on the numerator. Now we need to find the molecular weight of sodium chloride. Let us look up the periodic table. We can see that sodium has an atomic weight of around 23 and chlorine has 35.45. We add these atomic weights together, then we get the molecular weight of sodium chloride by simply adding them, which sums to be 58.44. Now we put this molecular weight value 58.44 in the denominator. Hence, we have the answer 0.154 mole. Therefore, 9 grams of sodium chloride is equal to 0.154 mole of sodium chloride. Suppose we have a container containing 1 potassium ion and another container containing 1 chloride ion, and they are made to react with each other. Then 1 potassium ion will react with 1 chloride ion to form 1 potassium chloride molecule. Now, if 3 potassium ions are made to react with 3 chloride ions, then 3 potassium ions will react with 3 chloride ions, forming 3 molecules of potassium chlorides. Therefore, we can say 1 mole of potassium ions will combine with 1 mole of chloride ions to form 1 mole of potassium chloride molecules. This means that 1 mole of potassium ions will need 1 mole of oppositely charged ions to form 1 mole of potassium chloride. That means 1 equivalent is 1 mole of oppositely charged ions that will bind chemically with potassium ions. So, 1 equivalent is equal to 1 mole potassium, or we can say that 1 mole of potassium ion is 1 equivalent because potassium needs 1 mole of oppositely charged ions. Calcium is a bivalent ion. It will accept 2 oppositely charged ions, for example, negatively charged chloride ions. Therefore, 1 calcium ion is neutralized by 2 chloride ions. Suppose we have 1 mole of calcium ions in a solution. It will need 1 mole of chloride ions to bind with 1 ligand and another 1 mole of chloride ions to bind with the other ligand to form 1 mole of calcium chloride molecule. Therefore, we need 2 moles of oppositely charged ions to bind with 1 mole of calcium ions. That means 1 mole of calcium ions is equal to 2 equivalents, or 1 equivalent is equal to half mole of calcium ions. 1 mole of calcium ions is equal to 2 equivalents, which we know by now. It means 1 mole of calcium will require 2 moles of oppositely charged ions. 2 moles of calcium will be 4 equivalents, which means 1 mole of calcium will require 2 moles of oppositely charged ions. So, another mole of calcium will require 2 moles of oppositely charged ions. So, it is 4 equivalents. 3 moles of calcium will be 6 equivalents because each mole of calcium will require 2 moles of oppositely charged ions. Here there are 3 moles of calcium, but since each calcium will require 2 moles of oppositely charged ions, hence 3 moles of calcium ions will be 6 equivalents. Here you will be able to see the equation of calcium chloride in moles and in equivalents. 1 mole of calcium reacts with 2 moles of chloride ions to form 1 mole of calcium chloride, whereas 2 equivalents of calcium will react with 2 equivalent of chloride ions to form 1 equivalent calcium chloride. Since we know 1 mole of calcium is equal to 2 equivalents, so in the molar equation, 1 mole of calcium will be 2 equivalent calcium. We know 1 mole of chloride ion is equal to 1 equivalent. So in the molar equation, 2 moles of chloride will be 2 equivalent. Now in this example, you can very well differentiate between the molar equation and the equivalent equation. Let us take the example of a nitrogen ion. Nitrogen is a trivalent ion. It will accept 3 positively charged ions to neutralize it. In this case, 3 hydrogen ions, which are positively charged ions, have neutralized nitrogen to form 1 ammonia. Therefore, 1 nitrogen will react with 3 hydrogen ions to form 1 molecule of ammonia molecule. That means 1 mole of nitrogen will require 3 moles of hydrogen to form 1 mole of ammonia. Therefore, we can say that 1 mole of nitrogen is equal to 3 equivalents, or 1 equivalent is equal to 1/3 mole of nitrogen. Now can you say 3 moles of nitrogen is equal to how many equivalents? It means we have 3 moles of nitrogen ions, but each mole of nitrogen ion will require 3 moles of oppositely charged ions. Therefore, 3 moles of nitrogen ion will require 9 moles of oppositely charged ions to form 3 moles of ammonia. That means 3 moles of nitrogen is equal to 9 equivalents. Let us see the relationship between mole and millimole. 1 mole is equal to 1000 millimole, or in other words, 1 millimole is equal to 1000th of a mole. Similarly, 1 equivalent is equal to 1000 milliequivalent. Therefore, 1 milliequivalent is equal to 1000th of an equivalent. 1 mole of nitrogen is equal to 3 equivalents. We can also say 1 millimole of nitrogen is equal to 3 milliequivalents. Similarly, 1 equivalent is equal to 1/3 mole of nitrogen ion. Therefore, 1 milliequivalent is equal to 1/3 millimole of nitrogen ion. Remember, when we talk equivalence, that means we are talking about electrolyte in a solution, because equivalent measures the chemical combining activity of an electrolyte in a solution. The chemical combining activity depends on two factors. Number one, total number of ions in a solution. More the ions in a solution means the more chemical combining activity. Lesser the number of ions in a solution, lesser is the chemical combining activity. Number two, the valence or the charge of the ions. That means more the valency, more is the chemical combining activity. Less the valency, less is the chemical combining activity. Let us see the mathematical equation for an equivalent. Equivalency is equal to total number of ions in a solution multiplied by the valence or the charge of the ions. That means equivalence is equal to moles into valency. Moles speak of the number of ions in a solution. So, if we multiply the amount of moles with the valency of the ion, we get the equivalence. We already know that mole is represented by the equation amount of the substance in grams divided by the molecular weight of the substance in grams. When we say equivalence, we consider moles or number of moles in a solution. When we consider milli-equivalent, we consider the number of millimoles that are there in the solution. For moles, we consider the weight and the molecular weight in grams. For milli-equivalents, we consider the weight and the molecular weights to be in milligrams. Just keep this in mind. Here we have a solution containing sodium chloride. And we will be calculating this in millimoles. So we know millimoles is equal to amount of the substance in milligram divided by the molecular weight of the substance in milligram. So what is the total amount? The total amount is 9 grams of sodium chloride is present here. We know the molecular weight of sodium chloride is 58.5 milligrams. So now we use the millimole equation, which is total weight in milligram divided by the molecular weight in milligram. So total weight is 9,000 milligram. We have converted 9 grams to 9,000 milligram here, divided by the molecular weight 58.5. And the answer is 154 millimoles. So it means 9 grams of sodium chloride is equal to 154 millimoles. Now let us convert the millimoles into milli-equivalent. We know milli-equivalent is equal to millimoles multiplied by the valence. Here, we know that there are 154 millimoles of sodium chloride. The valence of the salt sodium chloride is 1. Remember, the valence of any salt molecule is always 1 since it is not in ionic state. So the answer is 154 milli-equivalent. That means 154 millimoles of sodium chloride is equal to 154 milli-equivalent of sodium chloride. One sodium chloride molecule dissociates into 1 sodium ion and 1 chloride ion. 154 millimoles of sodium chloride will give 154 millimoles of sodium and 154 millimoles of chloride ion. Now, if we multiply the molar value with the valency of each, we get the equivalent value, that is the milliequivalent value in this case. Therefore, 154 milliequivalent of sodium chloride will split into 154 milliequivalents of sodium and 154 milliequivalents of chloride ions. One molecule of calcium chloride dissociates into 1 ion of calcium and 2 ions of chloride. Therefore, 1 millimole of calcium chloride will dissociate to form 1 millimole of calcium ions and 2 millimoles of chloride ions. Now, if we multiply the molar values with the valency, then we get to see this. That means 1 milliequivalent of calcium chloride will form 2 milliequivalents of calcium ions and 2 milliequivalents of chloride ions. Now you can see the difference in the molar value of calcium chloride and the equivalent value of calcium chloride. The difference in the values of moles and millimoles is brought about by the valence of the ion or the charge of the ion. Just keep this thing in the mind. Let us see in this example with 1 gram of anhydrous calcium chloride. 1 gram of calcium chloride is converted into milligrams, which is equal to 1000 milligrams. We will use the formula for millimoles, which is equal to weight of the substance in milligrams divided by the molecular weight of the substance in milligrams. The total weight is around 1000 milligram, and the molecular weight of calcium chloride is 40, which is the atomic weight of calcium, plus 2 times the atomic weight of chlorine, since calcium chloride contains 1 calcium ion and 2 chloride ions. Now when we simplify this, we get a value of 9 millimoles. So, 1 gram of calcium chloride is equal to 9 millimoles. We can see that 1 calcium chloride dissociates into 1 calcium and 2 chloride ions. 9 millimoles of calcium chloride will dissociate into 9 millimoles of calcium ions and 18 millimoles of chloride ions. We know milliequivalent is equal to millimoles multiplied by the valence. So, we convert the millimole values into milliequivalent values by multiplying them with their respective valences. Now, we get 9 milliequivalents of calcium chloride is equal to 18 milliequivalent of calcium ions and 18 milliequivalent of chloride ions. Therefore, 1 gram of calcium chloride is equal to 9 millimoles. 9 millimoles of calcium chloride will give 9 millimoles of calcium ions and 18 millimoles of chloride ions. 9 milliequivalents of calcium chloride will give 18 milliequivalents of calcium ions and 18 milliequivalent of chloride ions. We know milliequivalent is equal to millimole into the valence. We can also write that as milliequivalence is equal to weight by molecular weight into the valence. Now, if we interchange their places, we can have this equation as weight is equal to milliequivalent into molecular weight divided by the valence. Just interchange their places and we get the value of weight. Now we can use this formula. We know 9 milliequivalents is equal to 1000 milligrams. Now we use the weight formula here to find how much does 18 milliequivalent of calcium ions weigh. In the milliequivalent part, we write 18, which we multiply by the molecular weight, and we divide it by the valency of calcium, which is 2. We get a value of 360 milligrams. Place the formula of weight. We place the milliequivalent value of chloride ion multiplied by the atomic weight, which is 35.45. Since the valency is 1, so we write valency 1 in the valency area in the denominator. Hence, we get a value at around 638 milligrams. So you can see from the equation of milliequivalent, we can get the equation of the weight of an element or an ion. Easy, isn't it? In this example, we have a normal saline bottle which contains 500 ml of normal saline, which is 0.9% sodium chloride. That means there is 9 grams of sodium chloride in 1 liter of the solution. So we know millimoles is equal to amount by the molecular weight. And we know the amount is 9 grams, which is 9000 milligrams, divided by the molecular weight of sodium chloride, which is 58.44. So we put their respective values as 9 grams divided by 58.44, 9 grams to be converted to 9000 milligrams since we are equating in millimoles. So 9000 milligram divided by 58.44 milligrams will give the value 154 millimoles. We know one sodium chloride molecule dissociates into one sodium and one chloride ion. Therefore, 154 millimoles of sodium chloride will give 154 millimoles of sodium ions and 154 millimoles of chloride ions. Now, to convert it into milliequivalents, what we can do is to multiply millimole values with the respective valencies. Hence, we get 154 milliequivalent of sodium chloride will have 154 milliequivalent of sodium ions and 154 milliequivalents of chloride ions. I have a question for you now. We have a 500 ml of a normal saline bottle. Can you tell us how much sodium in milligrams is present in this sodium chloride solution? Come, I will walk you through the solution of this question. We have 0.9% sodium chloride, and we have to find how much sodium chloride is in 1 liter of normal saline. So there is 9 grams of sodium chloride per liter. The molecular weight of sodium chloride is 58.44. The molecular weight of sodium is 23. So we know the equation of milliequivalent. So milliequivalent is equal to millimoles into valence. And we further break the equation. Then we find milliequivalent is equal to weight in milligrams divided by the molecular weight in milligrams multiplied by the valence. So we put the values of weight and the molecular weight and the valence. We get 154 milliequivalent of sodium chloride is present in 1 liter of normal saline. Therefore, 154 milliequivalent of sodium chloride will dissociate into 154 milliequivalent of sodium plus 154 milliequivalent of chloride ions. Now that was in 1 liter of the solution, but out here we have 500 ml. So in 500 ml, we'll have half the amount of sodium chloride that's in a liter. So that counts to be 77 milliequivalent of sodium chloride. And 77 milliequivalent of sodium chloride will give 77 milliequivalents of sodium plus 77 milliequivalent of chloride ion. Now we know the equation milliequivalent is equal to weight by molecular weight multiplied by valence. Now we interchange the places to find the weight formula. So the weight is equal to milliequivalent multiplied by the molecular weight and divided by the valence. So weight is equal to 77 milliequivalent of sodium multiplied by the molecular weight of sodium, which is 23, and divided by the valence 1, and we get a value 1771 milligrams of sodium is present in a 500 ml of normal saline. So 500 ml of normal saline has 0.9% sodium chloride, which means it is 1771 milligram of sodium. Earlier, we saw that the requirement of sodium is 1 milliequivalent per kg per day, and the requirement of potassium is 1 milliequivalent per kg per day. Let us now convert the milliequivalent to milligrams. We know that weight is equal to milliequivalent into molecular weight by valence. So we replace those values. The milliequivalent is 1 multiplied by the molecular weight, which is the atomic weight of sodium is 23, divided by the valence. And we can say now that sodium requirement per day is 23 milligram per kg per day. Similarly, in the case of potassium, which is also 1 milliequivalent per kg per day, we place the values 1 milliequivalent multiplied by the atomic weight of potassium, which is 39, divided by the valence, we get the milligram value of 39 milligram. So we can say the requirement of potassium per day is 39 milligram per kg per day. So the daily maintenance summary can be updated in this way: 30 ml water per kg per day, 23 milligram per kg per day for sodium, potassium is 39 milligram per kg per day, and dextrose 100 grams per day. Earlier we also saw 1 milliequivalent per kg per day of sodium is needed, and that is served by 4 grams of sodium chloride. Now let's see. A 70 kilo man will require 1 milliequivalent of sodium per kg per day. So he will be requiring 70 milliequivalents of sodium per day. We know 1 milliequivalent of sodium will dissociate into 1 milliequivalent of sodium plus 1 milliequivalent of chloride ion. So 70 milliequivalent of sodium chloride will dissociate into 70 milliequivalent of sodium and 70 milliequivalent of chloride ion. We know the molecular weight of chlorine is 35.453. Molecular weight of sodium is 22.989. So we use the weight formula now. Replace those values. The weight will be 70 multiplied 58.5, which is the molecular weight of sodium chloride. We get a value 4000 milligrams. So that is the reason 4 grams of salt will give us sodium of value 1 milliequivalent per kg per day. This applies to a man weighing around 70 kg. Sodium bicarbonate injections are sometimes used to correct metabolic acidosis. We have a patient, Mr. Bakshi, who weighs 70 kilograms. Mr. Bakshi needs sodium bicarbonate 5 milliequivalent per kg per 8 hours. You have sodium bicarbonate 4.2% 5 ml ampules. Now the question is, how much ml of sodium bicarbonate are you going to load in the infusion bottle over 8 hours? That means how much sodium bicarbonate you're going to load or give in 8 hours to Mr. Bakshi. The clue is the molecular weight of sodium bicarbonate is 84. In order to approach this question, find his requirement of sodium bicarbonate based on milliequivalent. Find the quantity of sodium bicarbonate in milligram in 1 ml. Then find the quantity of sodium bicarbonate in milliequivalent in 1 ml. Now let's do these 3 steps. His weight is 70 kilograms. He will be requiring 5 milliequivalent per kg. So we multiply 5 with 70 his weight, and which comes out to be 350 milliequivalent per 8 hour. Now let's go and find the second point. That is, we need to find sodium bicarbonate in milligrams per ml of the bottle. We have 4.2% 5 ml ampule, right? So 4.2 multiplied by 10 is equal to 42 grams of sodium bicarbonate in 1 liter solution, which means we have 42,000 milligram sodium bicarbonate in 1000 ml solution. That means we have 42 milligrams of sodium bicarbonate in 1 ml of the solution. So we got the answer to the second point also, that is 42 milligram is there in every ml of this solution. Now let's find the third point. Find the quantity of sodium bicarbonate in milliequivalent in 1 ml. We got the value in milligrams per ml. Now we will convert the value of milligrams to milliequivalents in 1 ml. 42 mg sodium bicarbonate in 1 ml solution, which means we have to use the milliequivalent equation. Milliequivalent is equal to weight by molecular weight multiplied by the valence, and from there we get the value easily. We put the weight as 42 mg multiplied by the valence of sodium bicarbonate molecule, which is 1, and divide it by the molecular weight. We get 0.5 milliequivalent of sodium bicarbonate per ml of the solution. So we got the third point cleared. We need to give 350 milliequivalents total in over 8 hours, and the solution has 42 mg sodium bicarbonate per ml, which means it has 0.5 milliequivalent sodium bicarbonate per ml. Now each ml is equal to 0.5 milliequivalent sodium bicarbonate. That means he will need 350 milliequivalent of sodium bicarbonate per 8 hour. So we divide 350 ml of the liquid by 0.5, which means 700 ml of sodium bicarbonate needs to be given in 8 hours. So you should load 700 ml of sodium bicarbonate into the infusion bottle and set it over 8 hours. Let's have a quick recap of what we studied. Just a brief summary. Mole is a measure of quantity, that is the number of ions or molecules or atoms that are there in a solution. Mole is equal to total weight of the substance in grams divided by the weight of 1 mole of the substance. Whereas equivalent is a measure of quantity and the charge, that is the valence. So remember the formula: equivalence is equal to moles into valence. Mole is equal to total weight of the substance in grams divided by the weight of 1 mole of the substance. 1 mole means molecular weight. Equivalence is equal to moles multiplied by the valence. So equivalence is equal to weight divided by the molecular weight multiplied by the valence. Here are 5 multiple choice questions for you to solve for free. Please click the link below in the description box. You will be redirected to a Google form where you will be asked 5 questions. Select only one answer for each question. Each question will carry 5 marks. Trust me, if you can solve these questions, your concepts on moles and equivalence will be very solid and concrete. If you score 15 out of the 25 maximum marks, you will qualify for the next part of the video on IV fluids. Thanks for watching. Please like, comment, share, and do subscribe to my channel. Click the bell icon in order to get updates about further videos that I'm going to post for you.